All right, we'll go ahead and get started. How many here have worked with something like Apache, some open source software systems before, frameworks? Okay, just one or two of you? All right. So let's get down to more specifics. Who here has worked with ActiveMQ? Okay, few less. How about something like Karaf or OSGI? All right, Camel? Okay, I'm just going to keep doing this, and then we're going to get our exercises in. So, CXF. All right, excellent. So a little bit of background in these is going to be helpful today. Basically, I'm going to be hitting you with a fire hose. And there's a lot of information in these slides. This is basically 2 weeks worth of work compressed into 1 hour. So what you get to see now is kind of the general guidelines of some of the stuff that I have seen over the past couple of years in working with these architectures, utilizing those frameworks that we just talked about. So that's what you're going to get out of this. There's also some example code that you'll see near the end. You will have access to that via the website from Oracle. So anything that you see today, you will also be able to download. Let's hope this works. Yay! So who am I? I am an open source evangelist. There's not a problem out there that I don't think can't be solved. That was a double negative. Yeah, that can't be solved with open source. Almost everything out there has some sort of solution via open source. And the nice thing is that the reason why I find it so awesome is because if there's something wrong with it, I can go in and debug it. I can change it. That's the power. And then what I get to do is commit it back, which is even better. So if you guys aren't in the process of doing that right now, I highly encourage you to get involved. The reason being is then that way you're building a product that you're happy with, and you're allowing the rest of the people who are utilizing the framework to also take advantage of your knowledge. So there's my evangelism. Now I'd like to talk to you about Scientology. No, I'm just kidding. So who am I? I put this picture up there because it serves two purposes. One, it makes me look like a badass. Two, there's a slight alteration to this photo. And the reason why it's there is because being an SOA architect, there's a lot of little hidden gems in some of this software. On the surface, they look badass. You get to build these systems. They fit together really well, very easily. And everybody gets to, you show it to your PM and show it to the CTO or whatever, and it works great out of the box for your tests. The minute you put it into production, 10 minutes later, everything blows up, goes down, and then you're on phone calls for the next 5 weeks. But that's part of the idea of knowing what to do and what not to do from an SOA architecture. Now, what we're covering today are some of the basics, the general guidelines. I would say best practices, but we try to avoid saying best practice. The reason being is because best practices are going to be more aimed at what is best for you. And that's an individual decision. So what I like to say is general guidelines. This is where we're going to start. This is where I would normally start with most of the enterprise systems that I work with. Now, I'm not going to point out the alteration of the photo, but if you see it, don't mention it. I also get called into a lot of firefights. People go out, they assemble these products, they put them together, everything works hunky-dory in test, blows up in production. Hey, ActiveMQ is garbage, it won't work. It runs for 3 days and then just basically goes down. I have to go in and firefight, try to solve those problems for them. So that's where I come into the picture. I also do a lot of trainings, depending on what you're trying to achieve, whether it's CXF, Camel, we offer a lot of trainings too. So it's not only is it firefighting, but it's also trying to mitigate, to make sure that people do the right things out of the gate. So what are we covering today? There's quite a few things here. So we're going to touch on all of them, how to put them together. Because a lot of the stuff that you see out there on the web covers each individual piece. You can go out there and you can learn everything you want about Camel. Okay, but how do you get it to work with ActiveMQ? What's the general guidelines when putting that together? How do we build it into an ESB or Karaf or OSGI, however you want to say it? Enterprise architectures. This is the key. This is where everybody goes, okay, we need to get on the bus. Ooh, it's a buzzword. But what does that actually mean? What is it? There's a lot of products that end in ESB. Is that what it is? We're going to talk a little bit about what the ESB really is and how I don't like using the term ESB just because of what it stands for. Because it's not indicative of what you're actually trying to achieve. So integration. The whole purpose behind the ESB is to get everybody to integrate. I want to talk to system X, system Y, system Z, and then I want to pull all that information together. But I have to do it in a specific order. And I have to do it in a specific way. So I'm going to route this information in a specific way. And that's where Camel comes in. Camel's good for this. You'll see in very little amount of code, you can easily put together integration with multiple systems. But if you want guaranteed message delivery, if you want to keep those messages in a way that it allows you to scale and at the same time gives you guaranteed message delivery, you have to use a messaging system. It also helps prevent you against bursts, message bursts. Also gives you the ability to throttle, stuff like that. High availability, what happens if a system goes down? And more than likely, if you've used open source, you've seen a system go down. So how do you handle that? How complicated it is to set those things up? And of course, everybody's favorite OSGI. How many people in here have worked with OSGI? How many people in here want to work with OSGI? Okay, there were fewer hands. It's not that bad. I prefer it, but that's because I've been working in it forever. But it's a matter of getting over that hump, to getting things to work in that environment. You'll see some of the pros, and I'm sure you've run into the cons before too. The difference between Spring and Blueprint. Because a lot of people, when you hear the term Blueprint as an IOC, what does that mean? Oh, it's a whole nother IOC, and it's going to be complicated. I don't want to learn something new. Spring's been around forever. Blueprint isn't that different. And we'll take a look at some of the differences between them, and a lot of times people don't even realize they're looking at a Blueprint configuration file. And then, of course, the big term ESB. I'll just keep on. So this is the architecture we're going to look at today. And this is a general architecture that I run into constantly in the enterprise industry. It's a generalized architecture, but it fits a lot of the use cases that we constantly see in an integration system. So what we'll do is we'll just walk through this really quick, and then we'll tear it apart so you can see each part of this and how it's set up. Because what this provides is high availability on a high transaction type of system. So you can pass a lot of messages through this, and it can handle a lot of clients. As you can see, where's my run thing? At the top, the basic entry point for this system is going to be a web service call. Now this could be other things, it doesn't really have to be that, but it's just basically an integration layer where you're telling, if I can get it over there, you're telling other people how to communicate with you. And in this case, we're setting up, again, the ESB. The ESB is basically a proxy in this point. All you're really doing is giving your clients something to communicate with. Now, from that standpoint, what are you going to do with this proxy? The idea is here, you're just going to take information, you're going to, as quickly as possible, pass it on. You don't want to hold on to that information very long in the proxy layer. You want it to be fast, you want it to be thin. Because you want to be able to either to release that client or persist that information as quickly as possible. Because you can set this up either as asynchronous or synchronous depending on your use case. Which one's better? Depends on your use case. What are your requirements? Preferably, in my mind, asynchronous is going to work better, and that's the way it should be set up. But a lot of times requirements dictate otherwise. So inside the proxy layer, you can do things like this with Camel. So the web service proxy, basically, you're setting up a CXF endpoint, pulling that information in, and doing something with it. Whether it's setting up a transformation, you can decrypt or encrypt, depending on what you're doing with the information coming in, and then you persist it to ActiveMQ. These systems have to be very lightweight. The proxy needs to be thin, and you'll see why later. Because when you architect the system, You want to be able to scale your system at different levels. And you'll see why on some of the later slides. But so the idea here is that the proxy layer is very thin. You're not going to do a whole lot here. A couple of things, transformations, decoding, whatever. Maybe security, that type of thing. Then you've got your ActiveMQ layer. This provides a persistence layer. So you're passing it off to your ActiveMQ messaging layer. ActiveMQ has the ability to set up high availability with active and passive. This is where your guaranteed messaging comes in. Now, if for some reason ActiveMQ goes down, or your message layer, it will fail over and you've lost nothing. Your proxy layers will automatically switch over, and everything's hunky-dory, and you go into the annuals of your enterprise, of your company as the hero. And it didn't take anything on your part to fix it. It automatically does that for you. There's different ways of setting this up, and I'll show you some of those too. Because this is very important when trying to set up your system. Then down here, this is just kind of the fluff. This is where your business logic is. You know, whatever you're trying to achieve here. This is just a simple use case. Utilizing Camel to say, okay, I'm going to pull something from ActiveMQ. Got my leash here, I'm going to trip. You've got ActiveMQ coming in. In this case, we're just doing a multicast of two different beans, processes, doesn't matter. Those can be anything you want. I just called send mail and update database. But if you're familiar with Camel, anything in there. I mean, these are just routes. And then I'm aggregating the information. This is kind of what we're going to be going through today, just as a simple use case. The information that's in here really isn't that important. It's how you configure these systems to work together that really is the meat of the architecture. So let's take a look at some of the messaging systems. This is where you set up your high availability. This is also what's going to prevent you from overloading your system and give you the ability to handle bursts of data, that kind of thing, and also scale at different levels. So one of the first architecture, I guess, deployment options for ActiveMQ is the ability to set up a non-shared pure master slave. What this does for you is it gives you two different persistence layers, or two different persistence stores. But there's a problem with this. Does anybody know what the problem is with this? Raise hand? No?
Data consistency? I don't have that.
Yes, yes, yes. There's multiple stores here, so now you're paying the price. There's a step there. You're paying the price of data persistence on two different stores also. And you're paying the price of storing that data in two different places. Because the master cannot acknowledge this the message until it's been persisted. It has to be both places to maintain data integrity. Is there a use case for it? Of course there is. That's why it's there. And there's been several companies that said, based on our requirements, we need to do this. Fair enough. This is not the general guideline that I would suggest. Why? Because when the master goes down, the slave is specifically configured to attach to that master. So how does that happen? Can you guys see that code? It's not going to work. Well, if you can't see it, I apologize. But you're setting up the broker with the master connector URI, and then you're giving it its own data directory. Because you're setting up the master, you're telling it, here is my master. So you're defining master versus slave. It's not the best idea. The reason being is because once that master goes down, you failed over the slave, now you're stuck. You have to shut down your systems and copy data back over and then restart both systems. So you've got to have downtime available to your system in order to get this back online in a full HA environment. So is there a use case? Of course there is. This is a very fast failover also. It happens very quickly. It doesn't, because it's not based on locking mechanisms, which you'll see in a little bit. Here's the other deployment option. This is the one that's kind of the general guideline. This is the best practice, as they say. So what you're doing is you basically have two configurations. You've got a master and a slave, both pointed to the same shared persistence store. Now this can be file system, which is the general recommendation, is to say let's use a SAN, NAS, something. Or you can do it via JDBC. JDBC is going to be a lot slower because now you're paying the price of JDBC. But for people that are Oracle-based, MySQL-based, whatever, and they don't have availability to a SAN, it's another option. But it's not going to be performant. And I say that with sure confidence. It doesn't, wow, that was loud. It's not going to be as performant. So what does this look like? You're just pointing your database at the same data store as your slave. No special configuration needs to happen. Your master and your slave point to the same data store. That's it. So when the master goes down, your slave becomes the master. Now you can just fire up another instance of it and it becomes a slave. It's also a good process for migration. So now you can migrate your systems. So if you want to upgrade ActiveMQ, you can shut down 551, let it fail over, start up an instance of 5.6, shut down your slave of your 551, and boom, you're updated to 5.6. No downtime. Sure, it sounds that simple, right? It really is. One of the other things that's important is checking for corrupt journal files so that in case something happens when it shuts down, it'll correct those journal files. Older versions of ActiveMQ actually had an issue with that. So if we were looking at something that was using a database, it's very similar. You're just setting up the persistence adapter. In this case, for the database, it's JDBC persistence adapter. And then you're giving it a data source. That data source then sets up a table lock. So all it's doing is setting up locks, whether it's JDBC, it's a table lock. If you're using the file store, it's a file lock on that location. Now that also means that there's a delay in that switchover from master to slave. Because what that means is there's a certain amount of time between when one system shuts down and releases that lock from your file system, and that can be configured, but there is a delay. And you'll see that too because we'll demonstrate it. But it could be anywhere from 5, 10 seconds, that kind of thing. And plus, ActiveMQ is actively pinging for that lock. So your slave instance is sitting there checking to see when that lock is released. So once you have your high availability, how do you scale ActiveMQ? Well, ActiveMQ has this notion of network of brokers. So now we can have 2 active instances of ActiveMQ, which can provide a certain level of high availability. But with 2 active instances, you don't have that guaranteed message delivery. The reason being is because if you're just looking at the top 2, the masters, the master 1 and 2, and you're using 2 actives as your failover, they're not sharing data or a data store. They're not sharing the data store. So if one system goes down and it had messages on it, your clients will fail over. So they have the idea of high availability, but you're not taking up and picking up those messages that were in the store of the other active. So it's not true guaranteed message delivery, and it also doesn't provide you true high availability. This scenario does. Because now what you've got are 2 actives, 2 slaves, they fail over to each other. These 2 share a persistent store, these 2 share a persistent store. This guy goes down, he picks up, he becomes active, he reconnects to this guy, he starts sending his messages. Yes?
The arrows on the arrows between master 1 and slave 2 is one way, master 2 and slave 1 are 2 ways. Is that intentional, or should they have the same arrows?
No, they should have the same arrows. Thank you for pointing that out, appreciate it.
Is it both ways on all 4?
Yeah, I mean, it depends on which one goes down at any time, but all the connections are duplex.
Okay.
Yeah.
It was different. So.
Yeah. Appreciate that.
Thank you.
Yeah, no, thank you. So here's how you set this up, network of connectors. And as he had mentioned, setting up the duplex. That allows you 2-way communications across that connection. That's also good for if you're dealing with firewalls. If you're allowed a 1-way connection from a system that they don't want you establishing the connection one direction through their firewall, you can set up the duplex connection, and that allows you a two-way connection over one network connector. And then in this case, we're setting up a persistence adapter, KHDB. Yes? No. No, this has been here since 5. Are you talking about just the URI, or are you talking about the network connector itself, network of brokers? It's been there just as long. This has changed a little bit since it was like from 5.0 to 5.1. There was a change in the syntax a little bit, but that's been around since 5.1. But what this allows you to do is you're basically giving it 2 different sets of failover. So what you can do is stick a comma here and do another set of failover. So you can string together different failover groups. That way you're giving it more than one active master to connect to. One of the other important pieces to this, well, let me go back to the KHDB. You've got multiple options for persisting your data even in a file system level. You can use KHDB, there's the AMQ persistence store. There are different options. KHDB is going to be the best practice. And then, I hate saying that, it's the general guideline. And the reason because what this allows you to do is dynamic indexing on the file. Slows it down a little bit, but it pays off huge dividends when you fail over. Because we used to get people complaining, well, it's not failing over. What's happening? Well, our master's going down, the slave looks like it's trying to instantiate, but it just sits there. Okay. How big is your file store under which it's trying to start up with? Well, at that point, they had filled up their file store, so when they failed over, what ends up happening is it had to re-index that file. That could take as much as 20, 30 minutes. Not very many developers will sit there for 20, 30 minutes waiting for something to come up. So, of course, it looked like it locked. So this took away that problem. Now you get dynamic indexing on the file. It fails over almost instantly once the lock is released. Then you've got the transport connectors. This is how ActiveMQ is telling people to connect to their system. So this is how it instantiates those connections. Now the nice thing about this are these, well, there's more than these, but these are 2 of the more important parameters to know about when you're doing clustering, when you've got multiple masters. The reason being is because before 5.5, you had no instance or no way of telling it, well, I've got a bank of clients that are connecting to a network of brokers. Once they got that connection, that was it. They were connected to that master. No other option. So if you wanted to scale and you said, well, our system isn't handling it, we need to bring up another ActiveMQ instance, your stuff didn't scale truly, because unless your client went down and reestablished connection and knew about the new master or the new broker, it didn't do anything. So what this does is this now updates your clients to say, regardless of what my architecture underneath looks like, once I get a connection, update my clients with all of the URIs that are currently in my network of brokers. So now your client automatically knows about everybody else, even though he's not configured for them. And the nice thing is rebalancing. You can now tell it, drop the connections and let them reestablish, and that balances them across all clients. Yes? Are you talking about the rebalancing? It happens dynamically. So the client doesn't have to do anything. You don't have to sit there and tell the client to, well, somewhere in your code shut down. This does it automatically for you. So, are there any more questions about ActiveMQ? I know I kind of hit you with a lot of information. We're trying to put together the whole architecture really quickly. So, does anybody else have any more questions about ActiveMQ at this point? Yes? Yep. You can do as many. I'm not going to say that you can't infinitely do it, but yes, you can do quite a few. Yeah. Because that's going to have dependencies on your hardware implementations, what your environments are, things like that. The next piece is the CXF piece. This is your proxy. This is what's going to allow people to talk to you. Or you can talk to other systems this way also. So what is that? That's really tiny. But basically what this is this gives you the ability to look at or create an endpoint within Camel. So all of these slides are based on Camel at this point. So CXF is utilizing the CXF Camel component. You can also utilize CXF standalone framework. You don't have to use the CXF component. And there are cases under which I would say don't use the CXF Camel component. But for the simplicity's sake of this session, we're just going to embed it and use the Camel component. So all I'm doing here is setting up the information, setting up the address, the URL. What I'm trying to point out here is that within the configuration file, once I've defined this CXF Camel component, right there, that ID, I can now utilize that in my Camel route. So that gives me the ability to do the from. So now inside my Camel code, and I'm using Java DSL here, but you can also use Spring to configure it, I can now call CXF bean report domain. That's the published endpoint. I can now receive messages over CXF from that endpoint. Now in this case, I'm just doing a choice on it and saying, okay, using some simple logic to say, okay, well, based on the header information, the operation name, I'm going to do this. I'm going to convert the body and then I'm going to send it off to ActiveMQ. So that completes that first proxy layer in one, well, there's two configurations and I'll show you the other one in a minute. But in two configurations and this line of code, you've got that proxy layer. Very little code, very little work. That's what's awesome about it. You know, expect more excitement. I'm jazzed. So, you know, from the standpoint of a developer, I'm just like, this is the least amount of work I did. You know, I could do that whole proxy level layer in a day and then take the rest of the week off. So, this is the part that excites me. So now on the back end, where you saw that business logic layer, this is the code set up for that. Now again, you've got a little bit of configuration from the ActiveMQ standpoint, but that's it.
Can I ask a question?
Of course.
So, what's the container that's running all this Java stuff? Is this in the ESB or?
Great question. Did everybody hear that question? What's running this? Basically is the question. What runs Camel? Pretty much anything you want except Camel. You need some sort of container, whether it's Jetty, ActiveMQ, Karaf, which is OSGI, straight Java, and you can fire it up in the JE container. It doesn't matter. Camel will run in anything. I say anything, it's not going to run on C#. And there's limitations to my statements, but so yeah, this is basically within a configure statement of your Camel API. So now, this is that entire piece on the back end. I expected to hear cheers. You know, I mean, aren't you getting jazzed about that? Little bit of code, very little, to do all of that work. So let's walk through this real quick. What is it doing? It's pulling from ActiveMQ. I'm setting a header on my message, which is just basically, here's the identifier, and then I'm putting a constant of 1 in there. Then I'm multicasting to these 3 endpoints. Well, these 3 endpoints. Then I'm throwing it at a bean, and this is a bean that I've created, so there's no limitations to it. So just because it's a route, you don't have to use what Camel provides. It gives you plugins to say, I'm going to create my own processes, my own beans. There's no limitations to it. You can pretty much do anything you want to do, because if there's not an endpoint that supports what you want to do, or a component, you can write it. You just have to stay within the confines of the exchange patterns and stuff like that. But it's very simple to do. And then basically I'm taking these 3 external endpoints and I'm aggregating them back together. And in this case, I'm defining my own aggregation assembly strategy. So I'm going to tell it how I want it to pull these messages back together. And you'll see that right here. But we'll actually move the slide so you can see it. So this is just an aggregation strategy. From this standpoint, all I'm doing is I'm saying I've got an old exchange, I got a new exchange coming in. That new exchange gets reassembled, and then it processes back, and the one coming out of here is the one that's going to be old. Now, based on that, there's a general best practice. Whoops, wrong way. Wrong button. Just check for null on that old exchange. There's no sense in processing if you don't have anything in the old. But other than that, you work with the exchanges, assemble them the way you need. There are in Camel there are I guess predefined aggregation strategies for you, so you don't have to define your own. But you got to make sure that they do what you expect it to do, because a lot of times aggregation strategies, I would expect them to say, okay, if I've got 3 messages coming in and I say aggregate them, I expect it to join them together. A lot of cases, the defaults don't join them together. They give you the last one. So just make sure that the strategy that you're going to utilize fits your use case. So here's how you set up the ActiveMQ components. You see in these routes, ActiveMQ at the beginning. That's not a reserved word. You can use anything you want there. You're configuring that. So here's an example of setting up an ActiveMQ endpoint. In this case, I'm using the ActiveMQ component. You can use other things to talk to other MQ systems, whether it's IBM MQ, JBoss MQ, whatever. You can utilize the JMS component to talk to other JMS systems as well. So it's not something where you can only use Camel against a specific JMS implementation. Yes?
So in this case, are you just sending the request onto the backend as is?
Mm-hmm. Yep. Now, the one thing to keep in mind, though, is that the exchange object that's being utilized in Camel is not the object that gets put on the ActiveMQ. It's the body of the exchange that gets put on the ActiveMQ. So if you put something in the header of the exchange, that does not get propagated to the back end. So you lose whatever's in the headers of the exchange unless you put them into the body of the message, or as headers inside the message, or other properties inside the message. So in this example, this is just to show you that ActiveMQ is now the component name. So what I've named up here as the bean ID is now what I use here to make my call to ActiveMQ. I could use my MQ. I could use Heath's awesome ActiveMQ. It doesn't matter. It's just an ID. Yes?
So I don't have to write any JMS code at all, right?
Correct. So that's the bonus here. Like he had mentioned, you can get away with doing all of this with no JMS code. Now there are configuration strategies that you have to think about. Whether you're going to be, how you're going to be pooling your connections to ActiveMQ. Are you going to use the ActiveMQ pooled connection factory? Are you going to use the cache connection factory from Spring? Each one has a different payoff. Those are things you have to think through when you're configuring some of these things. But unfortunately, we've only got an hour, so I can't go through all of it. This is just to give you an idea of the difference between Blueprint and Spring. Yes?
Can you use Blueprint outside OSGI?
No. Well,
That's
yeah, I mean, there's I don't want to sound so definite when I say that. Yes, you can, but not in general practice. I haven't seen it used outside OSGI. But there are implementations like Jeff had said, that Pojo SR, that you can utilize. Yes? I'm sorry, I didn't hear that.
The endpoint for from or to, can that be a REST endpoint or a URL?
Yes, and it could be anywhere inside your route. And you can also set it up to be asynchronous communication with it, or you can set up to be synchronous. I mean, there's no limitations to how you can set that up. There are things you have to think about, like if there's an exception thrown, how do I handle, and that's a big, I'm just going to point that out right now since I'm on the topic. Exception handling is huge. Know your unhappy paths, because all the time through these routes, exceptions can be thrown. How ActiveMQ handles those may not be what you expect. So you want to be as specific as possible to say, I want it to do this, or I want it to do this. Because I want it to go back and I want it to retry this message. You have the ability to do that within Camel so that you can specify that I'm going to retry this message inside Camel before I acknowledge it. There's a lot of different possibilities in there, and you have to think through a lot of those unhappy type of scenarios. And just Camel testing isn't going to do that for you. I have a little snippet down here just to remind you guys of that too, is that you can do a lot of testing, but it doesn't test everything unless you set up full functional test suites. So just as a quick snippet, and this is a slide just to kind of show you guys that there's really not a whole lot of difference between Blueprint and Spring. A lot of people that I talk to are always, oh, you're going to use Blueprint? You know, we don't have Blueprint guys. We have Spring guys. And it's really not that different. As you can see, I mean, if you look at this configuration, it looks a lot like Spring. Really, the main differences are, oh, you got a Blueprint tag down there. Uh-oh. It's going to throw everybody off. And your namespaces are going to be different. And there's certain functionality that you get from Spring that you don't get in Blueprint. But you can put them both in the same environment. That's also the beauty of OSGI. So if we look at the difference here, really for a CXF endpoint, when defining a CXF endpoint, the only difference is that we've got, wrong button. We've got beans defined up here with different namespaces. CXF also requires some imports. In Blueprint, you don't need them. So it actually makes it a little cleaner. But if you look at how they're implemented, the same things apply. You're just defining the CXF endpoint, and then you're telling the Camel context where to start. So here's my favorite part, is defining ESB. What is an ESB? Everybody hears that term, and a lot of higher-ups like to throw that term around. But really what the ESB is it's a layer under which you can implement routing and integration and that type of thing. It's a buzz acronym, really. But in open source, the way we actually work with that is service mix. If you type in ESB, that's what service mix is defined as. It's your ESB implementation. What service mix really is Karaf. And what you're going to find is that Karaf is actually the underdriving engine of service mix. So a general guideline now is going to be use Karaf unless you have a reason to use service mix. And the reason being is Karaf is what provides you the main implementation of the OSGI layer. Karaf provides you the console. That's what allows you to start and stop bundles. It allows you to manage your deployment environment. Logging. You can change your logging levels. You can do different administration functions like setting up the configuration files. You can also do feature additions and adding URLs. Basically, everything can be done through Karaf. What does Service Mix provide you? More stuff on top. And a lot of times you're not going to use any of this. Well, it's not that you won't use it, it's just that most of it's, you want to only provide what you actually need. You don't want a whole layer of a bunch of garbage you're not going to use. Does anybody here use JBI? Exactly. That's my point. Oh, I'm sorry. He raised his hand at the end. JBI's slightly outdated. Not a whole lot of people using it anymore. But that's one of the things that Service Mix still provides. So if you're on JBI, yes?
The JAX-WES and JAX-RS, those are, the implementations are how easy to plug in and implementation?
Yep. From the standpoint of Service Mix, you do get a web service and a RESTful service Service Mix specific implementation, but a lot of times they're not used anymore. You're working with Camel. Now most of the time everything's going to be done through Camel. That's your main implementation and aggregation layer.
Hence using Karaf.
Exactly. Karaf with Camel does everything you would need Service Mix to do. And it's a much lighter weight container because you're not getting all of this. That's up, up above there. The JMS, the Spring, the JBI. You only implement what you need with Karaf. So from the standpoint of starting up a Karaf instance, what you're going to want to do is you're going to want to make sure that it's a clean a startup. So if you're in the process of utilizing something like ServiceMix, ServiceMix has all of these boot features already in there. So when you fire it up, you've got this long instance or long list of different features that it's going to install for you. This has been cleaned up slightly in the latest release, but I just wanted to point this out that it was installing a lot of garbage. Stuff you didn't need, stuff you weren't going to use. You also have the ability, which is powerful, to specify your own repositories. What that allows you to do then is specify your local Maven repository, whatever, and tell it, hey, I want to load these features in. And you can put those features into the features boot area, and every time Karaf fires up, it will automatically load those for you. So it gives you power over the implementation or the startup features of your Karaf implementation or ServiceMix. So once you get to the point where you're thinking about deploying all of this, the reason why I set up the original architecture the way I did is now it gives you the ability to scale at different levels, which is very powerful. You don't want to have to scale your proxy layer just because your business logic layer can't keep up. So now you can scale your business logic layer at a different level than your proxy layer. Because more than likely your proxy layer is thin, it can go very fast, it can handle a lot of connections. That's not going to be a problem. Your business logic layer is almost always the problem. And you have to provide for that. You also don't want to have to scale out your messaging layer just because you've embedded it within ServiceMix, which, by the way, you have the ability to do that. You can embed ActiveMQ not only in ServiceMix, but inside your code, whatever. You can embed those pieces. I'm going to highly suggest against that, because if you embed it and your code breaks it, it brings down the ActiveMQ instance also. Now you've lost the ability to throttle or keep things running until you get your service back up and running. So in most cases, you want to try and pull JMS out of your code or out of any embedded structure. Keep it as its own entity. That way, one, you can scale it differently, but also you can handle failover better. Hardware configuration. Whoa! This has a lot of lines on it. There you go. No, I'm just kidding. So this just kind of gives you an idea of how data is flowing through the system. So if you set up ActiveMQ with a network of brokers, high availability, 2 different SAN connections for your persistence layers, and then you've got your logic layers on the back end. It's a lot of arrows for a very simple design, really. The important thing here is that if at any time your ActiveMQ instance, one of your ActiveMQ instances go down, one of your proxy layers go down, one of your logic layers go down, and I mean one of your instances of the logic layer, not the whole thing, your system will still continue running. It may get a little slower, but it will continue running until you can restart that service, bring another machine online, whatever it is. This gives you high availability across your entire data integration system. You also have the ability to cluster. This is utilizing Cellar. What this gives you the ability to do is you can now deploy to a specific cluster, and it automatically will deploy it to both instances of ServiceMix inside that cluster. It's very powerful. Admins love that. The less they have to do to go to each box or run scripts or write scripts to do this for you, the more happy they're going to be. So in this case, we're just showing how we can take both of the proxy layer and the logic layer and put them in their own cluster. So if you're deploying bundles to either one or features to either one, in this case, you'd only have to run one script against one cluster. Yes?
Is the clustering part of ServiceMix, or is it also available for Karaf?
No, it's only, well, it's available for Karaf also. It is Karaf. When I say ServiceMix, I keep talking about ServiceMix. Karaf is the underlying pinning of ServiceMix. So, and basically they're synonymous in that case. So let's take a look at how you'd install it. All you're doing is adding a URL, telling it to install seller within the Karaf instance. This is actually what you see. Well, the next one you'll see it. This is how simple it is to install on Karaf. Now, once you've got it installed, you'll notice that here the prompt is a Karaf prompt, Karaf root. That's actually inside ServiceMix. So even the admin console says, I'm Karaf in ServiceMix. But here, what we're doing is we're setting up a cluster. First one there just says group list. I'm listing out the different groups I've got in my cluster. Then I'm going to create a group. And in this case, I'm telling it it's a proxy, which is that second line there. So I've created a group called proxy. I'm listing the groups again. You'll see now I've got a group called proxy in there. And then I can add or join my nodes to this group. So it allows you to start building out your infrastructure. So this, I just want to point that out because it's a very powerful tool for people trying to set up these larger enterprise systems and make it easier for you to manage. So looking one more time at the implementation. This is the code that I'm about to demo for you, which I hope works. We're going to set up two different bundles within a Karaf ServiceMix, which is this guy here and this guy here. And then we've got two instances of ActiveMQ running. We'll set up both of those so that they hit the same persistence layer. And then you'll see it fail over, continue running. We'll just hit it with SOAP UI. So are there any questions before I bring up the demo? Yes?
Are there any tools for the data center guys?
There's lots of tools for data center guys.
So what is the...
Oh, yeah, Karaf Apache. Well, yeah, I mean, basically there's no like pre-built tools other than JMX. So Visual VM, or I'm sorry, the JVisual VM and JConsole are basically going to be your best friends. Logging, you can use anything against the JMX APIs. Camel provides you basically the way of pulling information from JMX. Then you can use basically any monitoring you want, and they can usually tie into that using Camel. So Camel is a very powerful tool from that standpoint. Not only that, but ActiveMQ provides advisories, things like that, where you can get information from ActiveMQ when things start to fail. So if you start running out of memory or something like that, ActiveMQ will start throwing advisories before it gets to the point that it's going to fail. And that's all part of configuring ActiveMQ and Camel together to make sure that you get as much coverage as possible for problems with your enterprise environment. So there's a lot more to this. But we'll take a look at the demo real quick so you guys can see all of this working. Are there any more questions on this before I start into the demo? Outstanding. All right. Where's my mouse? Here we go. Okay. So basically I'm using Maven to, I've got it, I'm connected. So what I did at this point is I just built my two projects, the logic layer and the proxy layer. Now what we can do is let's start one instance of ActiveMQ, that's the slave. Hold on. Here we go. So here's the master ActiveMQ. This is the first guy that I'm going to bring up. This guy starts up. So this is my first instance of ActiveMQ that's going to be running. Now I'm going to go ahead and bring up the second instance. And you're going to see this guy stop. And as you can see, well, I don't know if you can really see that, but you can say that lock could not be established. That's because these two instances are pointed to the same file location. So just so you can see the difference between them, Now, once I stop this guy, you'll see this guy pick up. Boom, failover. Nothing special about this whatsoever other than the file location. That's it. So that one persistence adapter is aimed at the same file location. That's as simple as it is. Has anybody in here ever worked with like IBM with managers and things like that, where you have to actually set up and specifically configure everything manually? This is a much easier implementation. It really is as simple as what you just saw.
So to recover from this, do you just start your master and then?
Yep, so now my slave is taken over. I can switch back to my master, or my old master, restart him, and he'll sit there. Now he's in slave mode. So now it's literally, they've switched roles. You now have a master with a slave configuration again, because it doesn't matter which one's the actual, unless you're configuring it to have like a more high performance box as your master, and your slave is just there as a kind of a backup with less cores, whatever. So if that's the case, then yeah, now at this point, once you get your master back online, you'd want to switch back. So that's the ActiveMQ portion of it. Oops. So now with Service Mix, I'll go ahead and bring this up. So this is the Karaf console within Service Mix. This is what allows you to, let me make that a little bigger. This is what allows you to deploy your application. So down here at the bottom, you'll see POC Blueprint, POC Scatter Gather. POC Blueprint is my proxy layer. That's the one that just basically takes information and then figures out from the header what the operation was, and then sending it to ActiveMQ. The other one is a Scatter Gather. I'm pulling from ActiveMQ, basically doing a multicast on it, and then re-aggregating it all back together. So the way I show that is going to be SOAP UI. Let me go to the other screen here. All right. So you can see this is configured to go to the web service. And there's one other thing I should probably do, which is bring over the tail. So you can see it going through once this starts up. Bring that bigger. So here I'm just tailing the service mix log file. So you can see the information going through. Now if there's UI guys out here, this is really not that impressive. It's not like building a GWT app or a lot of flex stuff. But for you back-end guys, this is the meat. All right. All right, so you can see the message hitting the endpoint down here. There's my message exchange going through. It's aggregating. Basically what I'm doing is I'm setting it up so that it was just waiting on each one of the beans. The beans are just adding information to it. Really not that cool from a UI standpoint, but it's really neat from a simplicity of code and integration and routing standpoint. One of the other things I wanted to show you here is just how simple this code actually is. You saw it from a configuration standpoint on the slide. That's not going to be able to get big. Anyway, that's the amount of code it takes. Looks really small to you. But there's not a whole lot to this from the standpoint of once you've got it configured, it's really, really easy to use. The hard part is making sure you design and architect this correctly. That's the point that really has to get across. All of this is really easy, and like I said at the beginning of this, is that when you first go into this, it's really simple to pull it all together. And it's really simple to get these pieces to work together. It's not until you start pounding it with load that things start going wrong. And that's when configuration and knowing what you're up against really pay off. So from the standpoint of jumping into this realm, and that's why I was looking for hands based on ActiveMQ versus Camel and all that, is utilizing each individual component in and of itself on its own isn't that big of a deal. It's when you start integrating all of these pieces in an enterprise system. And the nice thing about this is that you can do it for free. It costs you nothing from an open source standpoint. It costs you plenty sometimes if you have to go with consultants, but that's why I'm up here. Yes.
This is more a comment than a question.
Uh-huh.
One of the great things about Camel and ActiveMQ is using the VM protocol.
Mm-hmm.
I could sit there and develop an entire enterprise architecture with multiple queues,
Mm-hmm.
multiple clusters in a single VM,
Mm.
test it all out, and then take it out and just distribute.
Right. Exactly.
Because I have a VM protocol.
He basically was making a comment. I don't know if you all heard it, but I'm paraphrasing now. He said it was awesome. But he was able to do a lot of architectural and configuration work on a single VM and then go ahead and distribute it in an enterprise environment very easily. Does that sound about right?
Yeah, I'm just saying, unlike WebSphere MQ or something, right?
Uh-huh.
ActiveMQ is just a single job.
Yeah, from the standpoint of the embedded and everything like that, yes.
And I could just connect to it using the VM protocol.
Right.
So my client is inside the same VM.
Yep.
My broker is in the VM. My Camel is in the VM. I
Right.
could literally build out the entire application inside a single VM and then take it out and then have all these network of brokers, have clustered
Right.
Camel instances, and then distribute it out. But as
Mhm.
far as whether it all works together very nicely,
Right.
you can just test out the whole architecture inside a single VM.
Right.
That's almost impossible to do with everything else.
Right. Yeah, exactly. Are there any other questions? Yes.
In my experience, the ops guys, they want to have some kind of a graphical console where they can configure stuff and do it themselves. Whereas in this, it seems like the developers configuring everything, and they usually don't trust us to do that. Well, but they have to know what's going on. They like to have colors and stuff flashing.
Yes. And well, there is actually the concept of web consoles in a lot of these frameworks. They're not quite drag and drop type of consoles, but it does give you a web console for a lot of the at least monitoring and some configuration of them. So like Karaf comes with a web console.
What was the comment?
Oh, I'm sorry. She was asking about, she was saying that a lot of the ops guys need something visual. They don't want to just say, well, the developers are all setting this up and we don't really know what's going on and we're okay with that. Most of the time ops guys are like, no, I need to know exactly what you're setting up, where you're setting it up at, how much is it going to cost, what's going on, and they want some nice little GUI to do it. Yes?
But just a comment on that, you can do that because it's all JMX based. And in addition to that, because you have the SSH console inside of Karaf, you can use products like Puppet or whatever and graphical tools in front of that to do everything you could possibly need to SSH in, do deployments for you, and there are GUI front ends even to that. So kind of the world is endless. If you need to get a pretty GUI for administration, you can certainly do it. You don't have to build it. You can use a lot of the pre-built stuff that's already out there.
It's assembling it. You still have to assemble a lot of these things, and you guys have to know how to write the scripts in Puppet and stuff like that. So there is a learning curve, but it's not something that's out of the box. It's not like a WebLogic system where you can sit there and say, here's a nice little visual thing, and I'm going to sit here and drag things around and configure it that way. But you can make it that easy with outside tools. It's not part of the Apache projects that allow you to do that.
You can use all sorts of different, even the really high big dollar consoles that have pretty flashing lights and that sort of stuff. You can absolutely point it at these stuff and it will work out of the box. Not for deployment, but for monitoring, setting up alerts, alarms, and all that sort of thing. So it works pretty well in that environment.
Does that answer your question, or yeah? Okay. Yes.
Sometimes you can also get over that barrier by documenting the frequent being used, like DevOps workflow.
Yeah. I'm sorry, I saw other hands. Yes.
Can 9x different DSL together, DSL and Java DSL?
Yes. Yep. You can add as many different contexts as you want using Spring or XML-based, Scala-based, Java-based. I think those are the three main ones that are available from Camel at this point. Yes.
It's also a little bit more complicated, not so positive. Once I used it and we set it up, it was great, until the point we had to go to production. First of all, when we had too much cores, it started to start them in the correct order. It was really annoying.
Uh-huh.
I think the bug is still open, by the way.
Yeah.
And two, error handling was
Right.
couldn't get it to work correctly.
Mm-hmm. Error handling from what standpoint, though? I mean, are you talking about within the bundles, or are you talking about when something in Karaf was?
No, the error handling is in Camel. So what to do with an error, I had to find several bugs with that.
Okay. Well, see, and that's the great thing about it, is that you can file a bug, and you can monitor the progress of it on your own without having to go through some corporation or support line or something like that, unless you're using Fuse or OpenLogic or Talent, or, well, not Fuse anymore. It's now Red Hat. So you've got other options from the standpoint of support and things like that, but that's the great thing about open source, is that you can actually fix the bugs if you'd like, and then submit them back to the community. Yes.
So instead of CXF, can I use the Spring MVC as a first-hand web?
Within Camel?
Together with Camel?
With Camel, yes. Yep. Not a problem. The question was, can you use Spring MVC with it? Don't use Spring integration, though. Just kidding. Was there another question? Yes? First time I got that question today. The presentation was done in Prezi.
What was it called?
Prezi. It's Prezi.
Sometimes we have to sell things, so it's sell it.
Yeah, it's and they've got a lot more. I mean, this is actually, I'm not that good with it. You can do a lot of stuff with it. I'm just rudimentary and got it to do what I needed it to do, but.
I was going to ask the same question.
Usually people ask that halfway through my presentation. What was this? Really? I got this whole architecture. It's really cool. You want to know about my presentation? Great. Shows I'm really, invigorating. Okay, is there anything else? Thank you. No? All right, thanks guys. Appreciate it.